Okay, so today we are going to do counting, which is also called permutations and combinations. And let me just get this thing done. Okay, okay. So yeah, I want to ask you this question: how well do you perceive counting as a topic? I mean, is it an easy topic for you? Is it a hard topic for you? Just wanted to get your opinion on it first.
Uh, Counting permutation combinations. I mean, it's like okay, and but I have lost touch, and
Okay,
I studied it long back, and probability is something which I have to work on.
okay, okay. Priyanka, your take on it?
Yeah, same as Lakshmi. I'm not proficient, but I think once we go through it, it shouldn't be too hard to catch on.
Okay, okay, okay. So let's start. Okay, so first of all, we will start with the most basic form of counting, and then probably we will make it more complex later on. Okay, just give me a moment. Okay, so let's say you have, we will start with, so I'll write counting here. Let's say you have two events, okay? Event A and event B. So event A can be done in, let's say, 2 ways, and event B can be done in 3 ways, right? So a question that usually that will be asked to you is, in how many ways both events can be done together, right? So in all counting questions, what I have a method which is pretty universal. It's called the slot method. In slot method, the steps are pretty basic, but it's doing those steps which is difficult. The first thing that you have to do is you have to draw the number of slots that are required. And then after that, you will fill the slots. That sounds easy, but this is the most difficult task. So let's start with this question. If the question says there are two events, event A can be done in 2 ways, event B can be done in 3 ways, in how many ways can both the events be done? Now the question is asking, if you just focus on what is the question is asking you. The question is asking you, in how many ways can both the events be done together? So what you're going to, sorry, what you're going to do is you're going to draw 2 slots because it's the number of slots. So you're going to draw 2 slots. So then once you fill the slots, now what you're going to do is you're going to start with any event that you like. Okay, in how many ways can event A be done? So event A can be done in 2 ways. In how many ways can event B be done? Event B can be done in 3 ways. And then you're going to multiply it. Why you're going to multiply it? Because let's say event A can be done in 2 ways, A1 and A2. Event B can be done in 3 ways, B1, B2, and B3. So A1 can be clubbed with B1, B2, B3, and A2 can be clubbed with B1, B2, and B3. So each is connected with 3, which is why you're going to multiply. So that means the total can be done in 6 ways. That's like the most basic of permutation and counting question. If event A can be done in A ways, event B 2 ways, event B can be done in 3 ways, the total number of ways that can be done is in 6 ways. Now comes the question of some possibilities, some cases. Let's make it more complex. Now, what I'm going to do is I'm going to make the question a little bit difficult. Now my question is going to be, let's say that there are 5 girls, A, B, C, D, E. In how many ways do you give 5 girls 5 prizes? So if I were to solve this question, if I use the slot method, what I'm going to do is I have to give away 5 prizes. That means I'm going to have 5 slots. And then I'm going to multiply these 5 slots. So in how many ways can I give the first prize? I can give the first prize to any 5 girls. 5. Now, how many ways can I give the second prize? Now here, you have to look at in every question, is the slot exclusive or not? If the slot is exclusive, that means if you've given this prize to someone and you can't give it again, that means the next slot can be given in 4 ways. The next prize can be given in 3 ways. The next prize can be given in 2 ways. And the next prize can be given in 1 way. Does that make sense, guys?
Yes.
Yes.
Yeah. So just as a little shortcut method is that if 5 girls wants to, if 5 prizes has to be given in 5 girls, so the answer is 5 factorial. So basically any n things that has to be given to in n ways can be done in n factorial ways, right? That is just, you know, just to make you quick in some small calculations, but usually you will do the slot method. Now let us make this a little bit more interesting now. What if I say that there are 5 girls and you want to give away 3 prizes? Or there are 3 girls and you want to give away 5 prizes. Can you tell me how many slots will you draw here?
3.
3 slots. How many slots will you draw here?
3.
3. So always draw the lesser number of slots, right? So that is the next complexity. So whenever you have to give n things in r ways, you always draw whatever is lesser, because don't draw something bigger. Otherwise, you'll run out of numbers. So always draw lesser number of slots. So if you want to give 3 prizes to 5 girls, it can be done in 5, 4, 3 ways. This can also be done in 5, 4, 3 ways. But understand, here you're taking the perspective of girls. That is, in how many ways can the first girl get a prize? Then in how many ways can the second girl get a prize? In how many ways can the third girl get a prize? And this is here you're taking the perspective of prizes. Okay, let's add a little bit of more complexity. Now the questions in GMAT will usually come with conditions. So when I say conditions, I mean, let's suppose that there are 5 girls and then there are 5 prizes. In how many ways 5 girls can get the 5 prizes if the third prize should go to girl C? So whenever there are conditions, the rule is always start with the condition. So whenever there are conditions, always start with the condition. So what you're going to do is you're going to draw 5 slots. In how many ways you can give the prize to girl C? That is 1 way. Now you're left with 4 prizes and 4 girls. That can be done in 4, 3, 2, 1 ways. So your answer is 4 factorial. Is that fine, guys?
Yes.
The condition, what was that?
Third prize has to be given to girl C.
Okay. So that is why there is only 1 way to give the prize. Okay.
Yes, yes. So you'll always start with the condition. See, if you wouldn't have started with the condition, then you would have had 5 slots and then you would have started with 5 first, right? So that would have given you the wrong answer. So that's why you always start with the condition first. Okay.
But if it was girl C, 5, 4, 3. Okay, so that means C would have got 3 ways of giving the prizes.
Yeah, I mean, you said, oh, how many ways I can give the prize to girl A? 5 ways. How many ways I can give a prize to girl B? That is 4 ways. How many ways can I give a prize to girl C? That is 1 way. So this would have been incorrect.
Yes, got it.
Now, the question could be, so this over here is a positive condition, right? Now, let's make it more complex. What if you have multiple conditions? So if you have multiple conditions, then what you do is, and if both, now let's talk with cases. If both the conditions are positive conditions, that is, in how many ways you can give the third prize to girl C and the fourth prize to girl A. So that means you can start with either of them, right? Or you can have positive conditions, but multiple positive conditions. Let's suppose in how many ways you can give third prize to girl A or B and fourth prize to girl C. So now you have multiple positive conditions. So then what you will do is you will first start with the bigger condition. So you have 1, 2, 3, 4, 5. Now what you will do is first you will give away the third prize. In how many ways can the third prize be given? The third prize can be given in 2 ways. Now go to this one. In how many ways can the fourth prize be given? The fourth prize can be given in 1 way. Now you have 3 prizes left and 3 girls left. So this is your answer. Is this making sense, guys?
Yeah.
Yes. So negative means like.
I will come to that. I will come to that.
Okay.
Yeah. The third complexity is, what if you have a positive condition and a negative condition? So the positive condition is that the third prize should go to girl A, and the negative condition is that the fourth prize cannot go to girl C. So this over here is a negative condition, and this is positive. So in here, what you will do is you will always start with the positive condition first, then go to the negative condition, and then go to all other cases. Because you want to give away whatever is supposed to be given, and then whatever is not supposed to be given, and then the other conditions. So here you'll have 5 slots. And then what you will do is you will give away the third prize first. In how many ways can the third prize be given? 1 way. In how many ways can the fourth prize be given? Now, 1 prize has already gone. That is the third prize. Fourth prize cannot be given to girl C. That means you're left with 3 prizes. And now you're left with 3 prizes and 3 girls, which is 3, 2, 1. Is this fine, guys?
Yeah.
Lakshmi Narayan, is that fine?
Yeah. Can you please repeat it once again? That would be great.
So here, what you'll do is you will start with the negative or positive condition first. So this is the third prize. This is the fourth prize. This is the first prize, second prize, and fifth prize. So in how many ways can the third prize be given? It can be given in 1 way, because there's only 1 way you can give third prize. Now A has already got a prize. Fourth prize cannot be given to girl C. You're left with 3 other girls. So this is why you have 3 here. And now you're left with 3 girls, because now C is available as well. You're left with 3 girls and 3 prizes, which is why it's 3, 2, 1.
Okay. Yeah.
So just gonna summarize. Whenever there are positive conditions, you start with the positive conditions. Whenever there are positive conditions but multiple positive conditions like this one, you start with a multiple condition. Whenever you have positive and negative conditions, you start with the positive condition first and then go to the negative condition. Now, let's make it a little bit more complex. What if you have positive conditions only, but the conditions clash with each other? When I say clash with each other, that means third prize should go to girl A or B, and fourth prize should go to girl B or C. Now, what is happening here? The conditions are clashing. This and this are not independent of each other. They both have a girl B in it. That means that if third prize goes to girl B, then fourth prize is only 1 choice left. If the third prize goes to girl A, then fourth prize is only 2 choices left. So which is why here you're going to have 2 conditions, different conditions. So here, what you will do is, instead of having just 5 slots, you will have 1, 2, 3, 4, 5 slots plus 1, 2, 3, 4, 5 slots. Why is that? Because now the conditions are not what do you say, they're not the same. So which is why you cannot just add it, put a 2 here and multiply. That's why you need to have different cases. See, what essentially you do is, when in counting, what you do is you count numbers 1, 2, 3, 4, 5, 6, and to save yourself time, you just say 2 into 3. That's what you do. But sometimes if the conditions are not similar, then you'll have to add. Am I making sense here, guys? Are you understanding what I'm saying?
Yes.
Yeah.
So here what you will do now is you'll start with any condition first. Let's start with the third condition. And then what you will do is you make that particular condition conditional. So I'm making the third price conditional now. When I say conditional, I will deliberately give the third prize to girl A here. And in the second case, I will deliberately give the third prize to girl B here. So of course, the third prize here can only go in one way, but here the third prize goes to girl A. Here the third prize goes to girl B. Now, if the third prize goes to girl A, then fourth prize only has fourth prize has two options left because it can go to B or C. But if the third prize goes to girl B, then fourth prize has one option left because B has already taken the third prize. B cannot get the fourth prize. And then essentially it is 3, 2, 1 and 3, 2, 1. Is that fine, guys?
Yes.
Lakshmi Narayan, is that fine?
Yeah.
Okay, I'm gonna do a small question just like this. So let's say you can give fourth prize to girl A or B, right? And fifth prize cannot go to, let's say, A or B. Okay, let's say the fifth prize has to go to girl B or C. Let's do that. So here what you will do is you will make this conditional. You can make this also, it doesn't matter. Now, since you have two different conditions, you're going to have 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 5. Now you give the fourth prize to girl A here. Here you give the fourth prize to girl B here. So that can be only done in one way. Now, but in this case, let's suppose if you talk about girls, A has already got a prize. B, fifth prize, can go to girl B or girl C. So it can go in two ways. But in this case here, fourth prize has gone to girl B. So that's why fifth prize, there's only one choice left. So that's why it's 1 here. And this is 3, 2, 1, and this is 3, 2, 1. Lakshmi Narayan, is that fine?
Yes.
Okay. Okay. All right. So that was pretty much what we're doing now. Till now, what we've done is permutations. When I say permutations, it means pretty much arrangement. That is what we've done, right? I asked you if I were to kind of, conclude what I just said. It is, in how many ways can you arrange n things in n ways? The answer is you'll have n slots and you'll have n minus 1, n minus 2. So that's basically n factorial ways. Or in how many ways can you arrange n things in r ways? So what you'll do is you will have r slots and then you'll have n minus 1, n minus 2 goes till r terms, which is basically npr. That is what you're doing here is SNPR, right? This is essentially what we've done is NPR. So what is NPR? NPR is in how many ways can you arrange n things in r ways. So what you do is you have r slots, right? And then you do n minus 1, n minus 2 till r terms. What is that? That is n factorial over r factorial. Is that making sense, guys? So I'll just add on that with an example. In how many ways can you give five girls 3 prizes? So you'll have 3 slots, which is 5 into 4 into 3, which is also 5 factorial divided by, oh sorry, it's n into n minus r. Sorry about that. 5 factorial divided by 2 factorial. which is essentially 5 into 4 into 3. Is that?
Yes.
What if R is more than N? Like
That is the condition in NPR always. N has to be greater than R.
Okay.
Yeah. Right. Okay. So this is like a shortcut way of doing things. But when you have cases, this kind of breaks down, because then you'll have to break it down, just like we saw here. Right. So that's that. Okay. So now let's move on to the next part, which is, instead of arranging, let's suppose, what if you are choosing? Things are a little different here, because if I say you have 5 girls and you want to make a team of 3 girls, or let's not call 5. Let's say you have 3 girls and you have to make a team of 2 girls. So again, if I use the slot method here, what will happen? I'll have 2 slots. I would say, okay, I can choose the first girl in any 3 ways. I can choose the second girl in any 2 ways. So the answer should be 6. But if we actually look at it, let's suppose there are 3 girls. The team can be AB, BC, CA, BA, CB, AC. You can pretty much see that these 2 teams are similar, which is why I have overcounted my teams. So what happened in choosing that did not happen in arranging? That is, in choosing, the order does not matter. The order in which you choose someone actually does not matter. But in arranging, the order does matter. Because if you give someone the first prize, or if you give someone the third prize, that is different than giving the same person the third prize and the other person the first prize. So when the order does not matter, what you do is you overcount. So what you have to do is you have to account for that overcounting. And in how many ways do you overcount? You overcount in the number of ways you're supposed to arrange things, or you're supposed to choose things. Here, what you've done is you've overcounted every team twice, right? You've overcounted every team twice. So which is why you have to divide by 2, and you can only make 3 teams out of it. So if there are n things, and out of n things, you have to arrange R things. Or other case, you have to choose R things. Here the answer is n factorial over n minus R factorial, or pretty much the slot method. But here what you have to do is you have to account for the overcounting. And how many times do you overcount? You always overcount R factorial times. Here you've overcounted 2 factorial times, because you can clearly see what is happening here. So which is why you have to divide the whole thing by R factorial. Or in the slot method, what you have to do is, if you have 3 into 2, you have to divide by the slot number. Slot 1, slot 2. Okay. Should I need to explain this again? I'll do an example also, but is this going fine? Are you understanding the basics behind it?
Yes.
Priyanka?
Yes.
So if I say that there are 5 people, out of 5 people, give me a team of 3. So you'll draw 3 slots, and you'll say 5, 4, 3, and you'll say 1, 2, 3. Right? So that is your answer. Okay. Is that fine?
Yeah.
Okay. You can use the C's and P's in like standard questions, but in most of the questions, you'll have to draw slots. Okay, now I will come to another conceptual topic in counting is, let's suppose you want to arrange n things, okay? in n ways? So the answer was n factorial, right? So let's say if you want to arrange A, B, C, D, E, how many ways you can do that? You have 5 slots, 5 factorial ways. But what if out of these n things, R things are identical? When I say identical, I say, okay, out of these A, B, C, D, E, A, B, and these 3 things, or let's say these 2 things, they are identical. C and D are identical. Let's call them C. They're same, but they are copies of each other. Then how would you arrange? Now, what is happening is you cannot differentiate between these 2, right? So what you have to do is you have to account for it. So in how many ways, how many ways you can do that, right? So let's try to do one thing. Let us assume that these 2 C's are different. If these 2 C's are different, then how many ways you can arrange it? You can arrange it in 5 factorial ways. But half of the times you would have C1 where you're supposed to have C2, and half of the times you have C2 where you're supposed to have C1. That means you've overcounted. How many ways you've overcounted? You've overcounted in the number of ways these 2 identical things can arrange themselves. That is in 2 factorial ways. So you have to divide by 2 factorial ways. So if I ask you in how many ways A, B, C, C, C can arrange itself, that is 5 factorial divided by 3 factorial ways. Just to generalize it, if there are n things, and out of those n things, R things are identical, then in how many ways can you arrange it? That is in n factorial divided by R factorial ways. And the application of these is tremendous. We'll go through that. But first I need to know, did you understand what I said here?
Yes.
Yeah.
Okay. So let's say in how many ways can you arrange the word banana? That is, you count 1, 2, 3, 4, 5, 6. 6 factorial divided by how many A's you have? 3, which are identical. 3 factorial into how many N's you have? 2. That divided 2 factorial. Okay. Is that fine?
Yeah.
This is going to spill over in probability as well. So you have to make sure that you understand this. Okay. Let's suppose if I say that there are 5 boys, A, B, C, D, E. In how many ways can you arrange 5 boys that C and D, C always sits to the left of D? So in this case, you have 5 boys, which is 5 factorial. And now you have a condition on C and D. C and D, they should not be, C should be to the left of D. So that means half of the cases C would be on the left of D and half of the cases C would be on the right of D, which is why you have to divide by 2 factorial. So there is a condition on these 2. Is that making sense, guys?
Yes.
Right. Okay. All right, let's do some questions. That was it. That was all about counting that you needed to know. So let me give you some questions. Oh, one more thing I forgot. That is sitting in a circle. So if there are 4 boys who want to sit in a circle, so this is place 1, place 2, place 3, place 4. Now in a circle, there is no first and there's no last position, right? So instead of having 4 slots, you're going to have 3 slots, because one slot is completely cut because there's no first and there's no last position. One position is always compromised. So if you want to sit in n ways, if there are n things, then how many ways can the n things be arranged in a circle? Is n minus 1 factorial. You're always going to have one less slot. Because if you think, okay, let's make the first boy sit. Where can the first boy sit? There is no position for the first boy. So the first boy can only sit in one way. And then when the first boy sits, all other boys sit according to the first boy, whether to the right, whether to the left, whether second to the right, whether second to the left. So first slot is always 1 for circles. Is that fine, guys?
Yes. And the remaining things would be like 1
3
and
to 1.
then 3 to 1. Yeah.
Yeah. Right. Okay. Two other types of questions that you might encounter is, let's suppose you have six boys and you have, let's say, 3 girls. In how many ways you arrange 6 boys and 3 girls? Of course, that's 6 factorial into 3 factorial. But if I say in how many ways you can arrange 6 boys and 3 girls such that all the girls are together. So what you do is, let's say you tie all the girls with a rope. You assume the girls to be one identity. So in how many ways can 6 boys and all 3 girls, which is one identity, can be arranged together? That is 7 factorial. But now the girls themselves can arrange within. That would be in how many ways can they arrange within? That is 3 factorial. Is that fine, guys?
No, I did not get it. Can you?
Okay. So you have 6 boys, and you have one whole group of girls. G, let's call it G. In how many ways can this and this arrange? You have 7 things to arrange. So the answer is 7 factorial. But the girls within can also arrange. You can have girl 1 first, girl 2 first, girl 3 first, or girl 3 first, girl 2 second, and girl 1 third. So in how many ways can that arrange? That can be arranged in 3 factorial ways.
Yeah. Okay.
Okay. Priyanka, did you understand this?
Yeah.
Okay. Another question that you might get is, in how many ways you can arrange so that no 2 girls are together? So then what you do is, you first arrange the boys. In how many ways can the boys be arranged? 6 factorial. So you have boy 1, boy 2, boy 3, boy 4, boy 5, and boy 6. Then what you do is you find the spaces. In how many ways can the girls be arranged? A girl can come here 1, 2, 3, 4, 5, 6, 7. There are 7 spaces in which you have to fit 3 girls. In how many ways you can do that? That is 7p3. Okay.
Yeah.
Lakshmi Ran, did you understand this?
Yes.
Okay, now let's go through some questions. Okay, why don't you solve this?
Is it 190?
I got 190.
Okay, so it says there are 20 players in a tournament, and if each of the players is to play each of the other players exactly once, how many total matches would be played? So to play a match, you need 2 players, right? So you'll have 2 slots. First, you can pick up any 20 players. Then you can pick any 19 players. But it doesn't matter if A is playing B or B is playing A. So the order doesn't matter. So the answer is 190. Okay, let's move on. So did you get the answer?
I got 14. C.
Okay. Lakshmi Narayan, did you get the answer?
Yeah, between 14 and 15. What am I missing?
So if she uses 4 colors, she differentiates file by variety of color combinations. She uses 4 colors to mark each file with 1, 2, or 3 colors. How many different color combinations she can generate? So first she can generate, so 1 color combination, 4, 2 color combinations, 4. Again, in combination, is green blue different than blue green?
No.
I don't think so. I think for this question, given the answer options, that is it is the same. So I'm going to say 4C2, then 4C3, and then 4C4, right? So 4 plus 4 into 3 divided by 2, 4 into, that's just 4 plus 1. So 4 plus 6 plus 4 plus 1. Sorry, 1. 12 is the answer. Did you understand, guys, what happened here? First, she can choose any. Oh, I think I made one mistake here. Hold on. First, she can choose any 4 colors as a single color combination. So the answer is, oh, and marks each file with 1, 2, or 3 of the colors. Oh, okay. See, that's when you underestimate a question. That's what happens. So how many ways she can choose one color out of 4 colors? That is 4 ways. In how many ways she can choose 2 colors out of 4 colors? That is 2 colors out of 4 colors. There's many ways. In how many ways she can choose 3 colors out of 4 colors? 4, 3, 2, and 1, 2, 3. So that would be so 4 into 3, it's 12. 12 into 2 is 24. So that goes. So your answer is 4 plus 4 plus 4, which is 12. Yeah. Okay. Did you guys understand this? That was an easy question, I think.
Sorry, it's 4 into 2 divided by 2.
Yeah, 4 into 2 divided by 1 into 2.
Why is it not 4 times 3?
Oh, sorry. See, I make calculation mistakes all the time. So your answer is 4 plus 6 plus 4, which is 14. Yeah. Okay. Which answer was essentially 4C1 plus 4C2 plus 4C3. That was the answer essentially. I just kept making calculation mistakes. Lakshmi, is that fine?
Yes.
Yeah. Okay. Here's one small little thing that I wanted to share with you. Go to that. Okay. This combinations, they are actually symmetric in nature. When I say symmetric, I mean to say that 4C1, 4C2, 4C3, and 4C4. So here you're going to have 4 over 1. Here you're going to have 4 into 3 over 1 into 2. Here you're going to have 4 into 3 into 2 over 1 into 2 into 3. Here you're going to have 4, 3, 2, 1, 1, 2, 3, 1, 2, 3, 4. So you can see what is happening is this gets cancelled, right? So essentially, what is it? 4C1 is actually equal to 4C3. So what is happening here? NCR, what is NCR? NCR is equal to n factorial over n minus r factorial divided by r factorial. It's actually equal to NCn minus r. That is also equal to the same thing. So 4C3 is actually equal to 4C4 minus 3, which is 4C1. So if you have like something like 8C2, that is equal to 8C6. If you have 9C5, that is equal to 9C4. 9C1 is equal to 9C8. Is that fine, guys?
Yes.
Yeah.
Okay. One more thing that might be helpful in your calculations is let's try to see what is 3C0 plus 3C1 plus 3C2 plus 3C3. So this is just 1. This is 3. This is essentially going to be 3C2 is going to be equal to this. This is 3. So this is going to be 1. What does that turn out to be? 6, 7, 8. So if you do 2C0 plus 2C1 plus 2C2, what does that turn out to be? That is 1 plus 2 plus 1, which is 4. So what I'm trying to show you here is the pattern that I'm trying to establish is that NC0 plus NC1 all the way till NCn is actually equal to 2 to the power n. Is that fine, guys?
Yes.
Okay. Okay.
Yeah.
Okay. All right. Why don't you solve this one? Let me know if you guys got the answer.
I'm not too sure on this one.
Okay, Lakshmi Ryan, did you get the answer?
I somehow got 40, maybe, but I'm not too sure.
Okay, so there are 5 points on this line. 1, 2, 3, 4, 5, and 4 here. 1, 2, 3, 4. How many triangles can be formed? So to form a triangle, you need 1 point from here and 2 points from here. So that is 5C1 into 4C2. Or you need 2 points from here and 1 point from here. That will make a triangle. So it's 5 into 4 into 3 over 2 plus 5 into 4 over 2 into 4. $70. Did you understand what happened here, guys?
Yes.
Yeah, it was all about making the cases. You had essentially it was like that question where you have to pick up to 1.1 price to this person, 2 price to this. It was a similar question, but the cases were different.
No, for the triangles, so by this, have we taken all the cases? 1, 2,
Yes.
3.
We have to pick 1 point from here, 2 points from here, 1 point from here, and then 2 points from here.
Yes.
Can you do it
Actually,
again by a slot method, not the C thing?
So by a slot method, you have to pick 3 points to make a triangle, and there are 2 cases here. First is you pick 1 point from here. How many ways you can pick 1 point from here? That is in 5 ways. You have to pick 2 points from here. And how many ways you can pick 2 points from here? That is 4 into 3 divided by 1 into 2. Then same thing here, 5 into 4 by 1 into 2, and then 4 over 1.
Okay.
Okay, shall I move forward?
Yeah.
Okay.
yeah.
All right, why don't you try this one?
I got 2520. C.
Lakshmi, Narayan, are you still solving it or did you get the answer?
I'm still solving it. Just give me 1 second. I'm getting a different answer. Maybe it's wrong. 2296. Some calculation mistake. Maybe.
Okay, so how many 4-digit even numbers are there with distinct digits? So it's a pretty loaded question in terms of content. So 4-digit, 4 slots, and they have to be even. So what is the condition? The condition is that this can be 0, 2, 4, 6, and 8. That is the condition. And the distinct digits have to be distinct. And there's one more condition, that this cannot be 0. So we have a positive condition, a negative condition, and the conditions are clashing as well. So we'll have 2 cases, 1, 2, 3, 4 plus 1, 2, 3, 4. We will first put 0 here. How many ways to do that? One way. If one way of doing that, then we will straight go here. In how many ways can this number be filled? 9 ways, 8 ways, 7 ways. Here, let's put 2, 4, 6, 8. How many ways to do that? 4 ways. Then how many numbers can be filled here? 0 cannot come here. One of these numbers cannot come here. So 8. Now 0 is available. 8, 7. Did you guys understand what happened here?
Zero. Why are we concerned about 0 here?
Because 0 cannot come here. And 0 is part of the condition here. So we have a positive condition and a negative condition, and both the conditions have one number common. So the conditions are clashing, which is why we will start with 0 here, put 0 here. How many ways you can put a number here? 9 ways, 8 ways, 7 ways. Then we will start with other numbers here, 2, 4, 6, 8. How many ways you can fill 2, 4, 6, 8 here? 4 ways. Now you're left, let's say you fill in 2. You're left with 3 numbers here. You can't even put in 0 here. So you're now left with 8 numbers. Like out of 1, 2, 3, 4, 5, 6, 7, 8, 9, you cannot fill 0 here, and you cannot fill one of these numbers here. So you're left with 8 numbers. Is that fine?
I'm still trying to understand. Just give me 1 second.
Priyanka, did you understand?
Yes. I when you did the second case, like you just took away, let's say 2, and then put the option as 4, as the number as 4 on the slot. Like I just put 1 and then multiplied the amount of case, because I just thought that it would still collide if you put 4.
Okay. Oh, so you just kept on putting 1 and 1 and 1 and 1. Okay, that makes sense.
But that wouldn't, I mean, this is much more efficient, right?
But so if you want to actually know the answer as well, you can see if you multiply this, figure out the last digit. The last digit is 9 into 8 into 7. What is that? That is 72 into 7. So the last digit is 4 here. Figure out the last digit here. 8 into 8, 64. 4 into 7, 28. 8 into 4, 32. So the last digit here would be 2. So the last digit would be 6. So B is the answer.
Okay.
Yeah, so you don't even need to solve it. Lakshmi Narayan, did you understand? Should I explain again?
Yes. So, but
Okay.
I did it in a different way.
Mhm.
Yeah, but yours is much efficient. Yeah, I was like totally messed up. Okay, just
So, so let's suppose you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you put in 0 here. Okay, so one way of doing that, you put 0. How many numbers you're left with? You're left with 9 numbers. Now you're left with 8. Now you're left with 7. In the other case, what you do is you put in any other number like 2, 4, 6, or 8. Let's say you put in 2. Here you can't even have 0. So 0 is also gone. How many numbers you have? 1, 2, 3, 4, 5, 6, 7, 8. Let's say you put in 9 here. But now 0 is available for selection. So you still have 8 numbers. Then you have 7. Is that clear now?
yes, actually, I missed that zero. That zero, though my calculation gave a rough answer with last number as 6, um, but I still missed that zero. So maybe my answer was accidentally correct.
Yeah. Okay. So let's move on. Okay, let's do this one.
I got 144.
Priyanka, did you get the answer?
Just 1 second. Yeah, I got 144.
Okay, so there are 6 tasks and 6 persons. Task 1 cannot be assigned to person. So, sorry. So task 1. So we'll go according to tasks. So 1, 2, 3, 4, 5, 6. Task 1 cannot be assigned to person 1 or person 2. Task 2 must be assigned to person 3 or 4. Yeah. So we'll start with task 3. 2 ways of doing that. And then we'll go to task 1. Task 1 cannot be given to 2 people and then 1 person from here, right? So it cannot be given to 3 people. So how many are left? 3. And then there are 3 factorial. So it's 6 into 3, 4 factorial. 4 into 3 into 2. So that is 24 into 6, 144.
Is there a reason that sometimes, like, you chose tasks? Like, can you, if you wanted, you could choose people, or because when I tried people, it didn't make sense, but when I tried tasks, I got the right answer.
So you said that like you
Like
started
assigning to the people. Yeah.
assigning people to tasks rather than tasks to people.
Yeah.
Okay, so task 1 has to go, cannot go. So you said, okay, how many ways can the first person get a task?
Yeah.
Okay, but then you'll have to start with a negative positive condition.
Yeah.
Yeah. So you'll start with the third one. It just makes the question a little bit more difficult to solve. That's what I would say.
Okay.
Because then you have to assign person 3 a task, and person 3 can get actually all six tasks possible. So you know, I would rather start with tasks than with people here. It's more
Okay.
efficient. Yeah. Lakshmi Rai, did you get the answer? Did you understand? I mean,
Yes.
okay.
Yeah, but I also did the same way what Priyanka did. Instead of tasks, it took the people. So it was slightly more to do. I mean, yours was much simpler. But yeah,
Yeah.
I don't know if
It'll come
it
with
would
practice.
take less time. Yeah.
It will come with practice. Yeah. Try this one.
I got 24. Maybe.
I'm not sure. I got something different. 60.
Okay.
I'm not sure either. I did it in a way I solved the previous one, like we had the triangle question that we had, so it looks similar to that.
Okay, so there are two models of cars available, model A, model B. So you have model A, which is available in blue, black, red, and green. Model B, blue, black, red, and green. 3 cars, so you'll have 3 slots. First, you can choose any 8. How many different combinations of 3 cars if all cars are to be selected of different colors? So let's say you choose blue. You can't choose this blue, so you'll have 6 left. This goes, that means you can't choose this. 4 left, divided by 1, 2, 3. So your answer is 32. So yeah, so I mean, first you can choose any 8 cars. Then you choose, if you choose, let's say, a blue car, you can't choose this blue car. So you're left with 6 now. Then you're left with 4.
I did it the same way, except I did 16, 14, and 12 because I just thought you can multiply, and altogether there are like 16 options. If you do if you're combining the models of the cars and the colors.
Oh, but there is like 8 options. I think you made.
Yeah.
Lakshmanan, did you understand?
Yes, but I tried like this. Like there are 2 models and 4 colors, and you have to select 3 cars out of this available options.
Yes.
So either 1 from model A and 2 from model B.
Okay.
Or 1 from model B and 2 from model
A. Okay, that makes sense. But then they have to be of different colors.
Yeah, so that I did not add in my equation. So I got like 4C1 plus 4C2.
So that would, so in your case, let's suppose we discard the color thing and we say, okay, pick up 2 cars. In that case, it'll be 4C1 into 4C2 plus 4C1 into 4C2. I mean, if we completely disregard the color thing.
Okay.
Yeah, but how would you incorporate having different colors? That's my question.
Maybe, that's what I missed actually.
Maybe what you can say is you can say 4C1 into now if let's say you've chosen blue, you can't choose the blue here. You 3 left, 3C2. Then you have 4C1 into 3C2. Maybe that can give you the answer. No, that does not. That actually undercounts it because 4 into 3, 12. So if you, let's suppose you choose a car from here, let's say you choose a blue car. Then from here, you only have 3 options left to choose. And when you choose a car from here, you only have 3. So going by your logic, it's like
I get 24, yeah.
4, you get 24. Yes. So where is what are those 8 options that you're missing? Think like that.
Yeah, correct.
So the 8 options that you're missing, and I'm just trying to think from your approach so that we can give this a closure. What are the 8 things that we're missing? Choosing 1 card from here and then choosing 2. Oh, so in this case, what you have missed is you have missed the possibility of choosing so let's say you choose a blue card from here, then you cannot choose the blue card from here. So you've missed that opportunity completely.
Okay.
So you have missed 1, 2, 3, 4, 5, 6, 7, 8. So you've missed those 8 options completely. Get what happened?
Yeah.
You understand what is
Got
happening?
it.
So that is why
Yes.
you're getting 8
Yes.
less. Yeah. Okay.
Okay. Thanks.
So let's give you okay. Let's try this one.
I got 48.
I got 28.
Okay, so a family consists of one mother, one father, two daughters, and a son taking a road trip. The sedan has two front seats. Okay, let's say, let me get my pen back. Okay, so the sedan has two front seats and three back seats. So one of the parent must drive. So you need to have a mother or a father here. And two daughters refuse to sit together. So you have mother, father, daughter one, daughter two, and son. So if two daughters refuse to sit next to each other, so what we will do is, we will, of course, a mother and father has to come here, but let's think about daughters. So that means they're either, one daughter can come here, of course, son can come here. Okay, so in here, what I will do is, I will start according to the seats. How many ways can a person sit here? Two ways, right? That's there. And here, what I'm going to do is, I'm going to make the seat conditional on the son, whether the son sits here or the son does not sit here. But what will make this that? Okay, so I have two people sitting here. Then I have either daughters at the back or daughter at the front. Okay, so two ways anyone can come here, mother or father. Then either of the two daughters coming here, two. If either of the two daughters come here, then three people can come in 3 factorial ways, plus two people coming here. Then daughter not coming here, so it will be mother or the son. And then here you have pretty much two ways. So that would be 2 into 2, 4, 4 into 6, 24, plus 8, 32. Let me make sure I'm doing it correctly. Yeah. So here's what is happening. I'm just going to discard this. How do I do that? Okay. So you have 2 seats and 3 seats here. So in the first seat, you'll have mother or the father. In the second seat, what I'm going to do is, I'm going to make that conditional on the daughters. Either the daughters sit here or the daughters don't sit here. So let's make the daughters sit here. So in how many ways they can do that? Two daughters can sit here. So if either of the daughters sits here, then these 3 seats can be that they can be filled in 3 factorial ways, because then you'll have one of the daughters and the son and the mother. Till now, is this fine?
Yes.
Yeah.
In the second case, any 2 people can come here. Then we don't want to make a daughter sit here, so it will be son or the mother. So that would be 2 ways. Now in here, you will have one of the daughters here, and whoever is left in here. And how many ways is that possible? 2 ways, because the daughters can arrange themselves in 2 ways. So your answer is 32.
Sorry, can you go over the second case again?
So you can have mother or father on the driving seat. Then you can have son or mother on the second seat. Then you're left with 2 daughters and you're left with son or the mother. How many ways can they arrange? Now, daughters cannot sit together, so they have to be on the opposite seats. So, and whoever is left is on the middle seat. And how many ways can that be arranged? That can be arranged in 2 ways, because daughters can replace themselves in 2 ways. They can come in this seat and the other daughter can go in the other seat.
Okay.
Did you understand that?
Yeah.
Lakshmi Rai, did you understand?
Yes. So again, I tried something else. So for parents, like there was one seat. If one was driving, the other parent can sit in 4 ways.
Okay.
Uh,
So
that
you
that
went. Okay. So other parent can
and
sit in any other 4 ways. Okay. And then what?
4 ways, and then the daughter now has one daughter has got 3 ways.
Okay.
The remaining seats, 3 seats she has.
But the problem here is the seats are not like equally arranged. That there is a hierarchy of seats. So you have to go by the seats here.
But will it matter if I just take the number of seats available and make people, if they are
But
sitting on the front seat or back seat?
but then you have the seats are different as well. You have 2 front seats and 3 back seats. When you say a mother can sit in any 4 seats, then
So
these 4
can
is a
either
very complex thing. You know, what if she sits here? That's a different case. What if she sits here? That's a different case.
no, but the driver seat is already taken by one parent. So the remaining 4 seats is what I was thinking.
But those 4 seats are not identical. You can only write the number 4 if all other 4 seats are identical. But that is not the case. You can bifurcate this 1 and 3. You can say, okay, let the mother sit here or the mother sit here. So there are 2 different cases.
Okay, so I just counted the number of seats available. And
But the seats have to be identical for you to count. So if you want to start with people, then you say, okay, let the mother sit on the front seat. Okay.
identical means I did not understand. I mean,
Identical means that it doesn't matter in what seat she sits. The other conditions are not going to be mattered by it. So if she sits on the second seat and in this front seat, that has a different proposition for the daughters than if she sits on the last 3 seats. That has a different proposition for the daughter. So when you choose a slot and when you put in a 4 here, your putting a 4 here should not change the numbers here.
okay.
That is
Okay.
what I meant by identical. I mean, it should not, I mean, they're different. So which is why you have to make cases here.
Then
Okay.
you know when the second case when you did in the back seats you did 2. Wouldn't why isn't like 1 1 1? Because the one of the daughters would have to sit in let's say the left, and then the mother would sit in between, and then the other daughter would sit on the right. So how is it coming as 2?
So what if, okay, so what if you can have daughter 1, mother daughter 2, and you can have daughter 2, mother daughter 1. So that is 2 different cases.
Okay. Yeah.
Is that fine?
Yeah.
Yes.
Okay. Okay, let's see this.
I don't think I'm getting anywhere in this.
Priyanka, are you getting the answer?
Like a complete guess, I would guess D.
Okay. So it says that how many different 5% teams can be formed from a group of X individuals? Okay. So the question is asking you, what is the value of XC5, right? First statement, it says, if there have been X plus 2 individuals, so if there have been X plus 2 individuals in the group, exactly 126 different 5-people team can be formed. Okay. Let's see what that means. So that basically means that X plus 2 C5 equals to 126. Okay. That is fine too. Let's see the second statement. It says if there have been X plus 1 individuals, X plus 1 individuals, C3 is equal to 56. Okay. I want to get a workaround using, try to see what will happen here. 5, 4, 3, 2. Okay. Let me see this 126. What is this 126? This 126 has a 63 into 2. That is 63 is 9 into 7 into 2. So it has to have a 7 in it, right? The 7 is a factor there. So for it to have a 7 in it, this has to be greater than 7. So it can't be, so 6C5 is not an option. Of course, that would not be the answer also. For it to have a 7 in it, going back 5, okay. And it definitely does not have 13 in it as well, or does it have? No. So 126 is 63, 3 into 9 into 7, 3 into 3 into 7 into 2. Okay, so this is what I have. X plus 2 is exactly 5, 1 people can be formed. I'm going to try. I know this will give me the value of X. I would say that this is sufficient, but I want to still get I just want to still get the value of X. So basically this is X plus 2 into X plus 2 minus 1, that is X plus 1 into X minus 1 into X minus 2. 1, 2, 3, 4, 5 divided by 5 factorial. So that is equal to 126 into 5 factorial. That is what it is. Okay. Let's see this one. This one seems easier. This is X plus 1 into X minus 1. 1, 2, 3 equals to 56 into 3 factorial. Okay. So let's try to wrap our head around this. So this is 8 into 7 into 3 into 2. And I have to make this a product of consecutive integers. So if I want to do this 4 into 2 into 7 into 3 into 2. So this is basically 8 into 7 into 6, right? 8 into 7 into 6. So x is 7. Yeah, right. X is 7. Any other possibility of getting xs to be different than 7? No, because x plus 1 into x minus 1, product of 3 consecutive integers is 56 into 3 factorial. So x is 7. So this is sufficient and x is 7. Let's go to the second one. And what I'm going to do is I'm trying to break this. So this is 9 into 7 into 2 into 5 factorial, which is 5 into 4 into 3 into 2. So this is 7, 6, 5, 8, and 9. I have a 9, I have a 7, I have an 8, I have a 10.
No, you have a 6 and a 5 as well. 2, 3, and then.
Okay, I have a 6 as well. Okay, so I have a 9, I have a 7. This is gone. Let's just wrap this out. I have a 10. Then I have a, oh, I think I made a small mistake here. So the 126 is 9 into 7 into 2. So 9 into 7 into 2 into 5 factorial. 5, 4, 3, and 2. So I have a 9, I have a 7, I have a 10, I have a 8. I'm missing a 2 here somewhere. I'm missing
You
one.
have 8, 6, and 5. Correct, right?
Oh, okay. So 9, 7, 3 into 2, 6, then 5, and then 8. Yeah. So that means x is equal to 7 works here as well. This is sufficient too, and D is my answer. Okay, is that fine?
Yes.
Yeah.
Yeah. So that was, I think, pretty much more computational than anything else. Right. Okay. Let's try one more. I want to give you guys a little bit practice on this topic.
How did you split this x plus 2 into this? Is it
Which one?
the? I mean, it could be a silly question, like, but you split this one, right? X plus 2 into x plus 1 into x.
That was like the slot method. So x plus 2 stays, and then it goes 5 terms back.
Okay.
Right?
Yeah.
I'm just trying to find a good question for you guys. Okay, let's see this one. Okay, let's solve this.
I got A.
Lakshmi, right? What did you get?
A or E. But I'll go with A. I'm just...
Okay. So it says that x and y are positive prime numbers. So x plus y is 12. So what are the prime numbers less than 12? 1, 3, 5, 7, 11, right? So
1 is a prime number.
1 is not a prime number. Sorry about that. 2, 3, 5. Okay, 2, 3, 5, 7, 11. So the only possible way you can get a sum is 7 plus 5. So that means 7 and 5. So it's 7C5. It doesn't matter whether there are more chairs or more people, you'll get the same answer. So A is the answer. Lakshmi, Ryan, did you understand?
Yes.
Okay. Let's get another one. Okay, let's see this one.
I got C.
Same.
Okay. So it says 5 sentences, 10 words, and each sentence should have 2 words, and they can't be used again. So basically, five sentences, 10 words. Each sentence must use 2 words, and no 2 words can be. So it's 10C2, 8C2, 6C2, 4C2, and then 2C2. So you can choose any 2 words, then any 2 words, then any 2 words, and then any 2 words. So that would be, so now the answer options are pretty different in that term. So how many different ways? Okay, select the words. Okay. So 10, 9 by 2, 8, 7 by 2, 6, 5 by 2, 4, 3 by 2, 2, 1 by 2. So what does that come out to be? 10 factorial over 32? Am I doing this correctly? Looks like it. Yeah.
Can you do it by the slot method as well, if you don't
Yeah.
mind.
Yeah. Yeah, I'm just verifying if I'm doing things fine. Now, 5 sentences, 10 words, and if each sentence must use 2 words and no 2 words can be used more than once. Okay. Yeah, so basically for the first sentence, you have 2 words. You can choose any 10 first and then any 9. That divided by 1 into 2, because it's asking you to select the words, not actually put them there. So it doesn't matter not what order you select them. Then the next sentence, you have 2 slots. You can choose any 8 and any 7, 1 into 2, and then it goes on like this. Okay?
Okay.
Lakshman, right? Is that fine?
Yeah. Yes.
Yeah.
But I think I used a totally wrong method.
Okay.
I tried to do the slot way, but I mean, yeah, I mean, it's wrong actually. It's
Okay. Okay. So you must have realized that the way of solving the problem actually decides whether you'll be able to solve it or not. It's the way of forming this particular thing, like how are you going to approach the problem? Are you going to take girls first, or prizes first, or people first, or tasks first? That pretty much decides whether the problem would be solved easily or it would be more difficult. So you just have to think like in the first first phase of the question solving. That's where it's pretty much decided. So try to focus more on that when you practice.
okay.
Okay, so do you have any, so I guess, I just wanted to cover counting today. Next class, I'll cover probability and set theory. So do you have any questions for me? Did you understand everything that we had?
Yes, but I have to practice a little bit more because for me it's not coming up smoothly the way you are doing.
Yeah, I mean, that is a
yeah.
function of just practice. I've been practicing this for so many years, so that is why it comes naturally to me. So you just have to practice and it will come. But maybe you have to practice, otherwise it will not come naturally to you.
Sure, yeah. So I'll practice, and I think I'll need help in this more.
Sure.
So I'll post questions on Slack or WhatsApp.
Yeah. Priyanka, do you have any questions for me?
No, I just like, for me, this whole, like, when you use the P and C and stuff, I'm just not used to that.
Okay.
So when I do a slot method, it's much more visually appealing for me. But do you think it's good to also learn those notations and try to do it that way?
See, essentially they're the same methods. So essentially there's no difference between both of them. But what I find appealing in the combination and the permutation is it kind of it kind of closes everything down to just one word. You don't have to draw too many slots. So if I have to pick up 3 things out of 8 things, I don't have to do this and this. I can say, oh, 8C3. So some problems which are complex enough where I have to go beyond this, let's say 8C3 into 7C2 into 6C4. So it becomes easier to actually frame the question. So essentially, this is kind of encapsulating the whole slot. I see it that way. So I don't see any difference between both of them.
Okay.
So the problem will come. The reason we do slot method is when you have to break this down. Like sometimes you have to break this 8C3 down in 6C2 and 7C1, 2C1. So sometimes you have to break it down like this. There are cases that are made. Then the slot method is very helpful. But if you can understand it in combination and permutation, that means you have understood the whole thing.
Okay.
Yeah.
Okay.
Yeah. Okay.
Yes.
All right. So I will post the questions and the video recording and the solutions as well on the course.
Okay.
Yeah. And have you guys written the practice test yet?
Yeah, I took one, and madam asked that day. I told I got. I mean, of course, it's like 540.
Okay.
And quant was really horrible. I got 26.
Okay.
And sorry. Verbal was horrible. I got 26, and quant was 32.
They're
So
equally horrible, actually. Yeah.
Yeah, I know that. Yeah.
Yeah. So share the results with me and go through every question in detail, especially the topics that we have covered, and then kind of if you're able to not understand a problem, if something is difficult, then share that with me. I would like to see the questions that you got wrong.
Yeah. Actually, I went through the review of those questions, and when I solved it second time, I mean, they were much better. I mean, because maybe of time pressure, the problem was the test wouldn't stop. If I pause it, the question wouldn't appear again.
Okay.
So what I did was I did a timed one only. So under time pressure.
So you can do is if the test software doesn't allow you, you can take a screenshot and pause the test.
Yeah. So I'll take another one now. This week I'll take another one.
Take an untimed test in the beginning. That actually helps you to see your performance without time. And time is something that you can always later on incorporate. First, you need to pin down the concept. That's important.
Okay.
Timing will come later on.
Yeah. So next test, I'll apply some trick. I'll take a screenshot or something, and then we'll.
Is it Manhattan
see how it
or
goes.
what tests are you taking?
I had Veritas.
Okay, I think you can, like, before starting the test, you can like change your time settings or something. If you cannot, then just take the screenshot. Yeah.
Yeah, I'll just explore those options. I mean, but next test I have to take it untimed, because timed is just giving me 540 and not even 550 properly.
Yeah.
So it's absolutely disgusting at the moment. So,
yeah, it's okay. I mean, that's part of the process. You have to go through the whole process. Yeah.
Okay. So this week I'll let you know the test results of the other tests which I take.
Okay. Yeah. Okay. Okay. So I will end the meeting now.
Okay. Thank you.
Yeah. Thank you. Have a good one.
Thank you.
Thank you.